it's a crucial moment in physics. We have a standard model of particle physics that we know is incomplete. We found the Higgs. Now it is time to actually understand the properties of the Higgs. How does it interact with the other particles in the standard model? We also want to look for hints of physics beyond the standard model. At the same time, this is also a infrastructure, a software grand challenge. In order to find information about the Higgs, in order to find signatures of physics beyond the standard model, we have to analyze large sets of data and throw away everything that we know and keep only the part of the data set that has the potential actually providing new answers, new physics. Why is that important? Well, we just can't store everything that the LHC produces. We do not have enough computational power. There's not enough computational power in the world to actually allow us to analyze these data sets with the existing tools that we have right now. So we have to take the next step. That's what this particular software institute is about, bringing together not only the US community and the global worldwide community in high energy physics, but bringing together also computer scientists, mathematicians, statisticians, to develop new ways of actually solving this particular problem in the hope that the solutions that they will be developing here can also be transferred to other sciences, to other applications.